Okay, okay. So this is the connection in your house. So, how do I say? It will be quite reliable. Hopefully, next time it will be something like this also. Hopefully, yeah. We'll see what happened today. Hmm. Okay, that's the first good news. All right. Okay, now second, um, how's your holiday? Has it been a holiday for you?
Yeah,
Um, you don't sound too happy about it.
I mean, it's it is a holiday.
Maybe what I mean is very specifically, have you had time to relax and, well, do nothing, lah, not be
Yeah,
productive for a while. Good, good, good. Um, is it enough?
yeah.
Good, good, good. Um, After holiday, most probably your school will ramp up. Everything will ramp up, lah, right? This is basically your last chance to have a holiday before the exam. Okay, so before all the stresses and all the hard work comes in, I do really wish that you did have a holiday, lah. You okay with us starting today?
Yeah,
Good, good. Now, tell me, um, have you been studying something? You don't have to. I just want to know. I just want to know how long have you went without studying?
I mean, I've studied a bit. Yeah,
You mean for chemistry or for other subjects?
yeah, for chemistry.
All right, all right. May I know how you studied for chemistry?
I just like read the notes and wrote what was important on the paper.
That means you read first for division, but practice paper maybe later lah, something like that.
Yeah,
Understand? Any progress on the note? No, 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 the note, the cheat sheet, right? The cheat sheet. The last time we met, I believe we are still talking about the cheat sheet, lah, right? Yeah, 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 yeah.
yeah,
So, any progress on that? It's okay if there isn't. I just want to know.
like yeah,
Then, if there is some progress, because it's for exam, yeah, because it's for the exam, right? Okay. May I see your current state of cheat sheet? It should be some sort of a summary of what you have learned, right? Definitely more than one paper, right? It was me who requested that. Do you mind if you send me something? Was that you? Yes, it is. Mhm. Mhm. Mm, okay, part of it was from me, and then ah, you decided to summarize it this way. Yeah. So these are the two half pages. Is there anything else? Kingdom in. Is there anything else?
no,
All right. Okay. Let me see your style and summary for a while. Okay. I'm putting it in a Jamboard already. It was your Jamboard, Ria02. Yeah. Would you kindly join me there? Okay. Now see. Definitely what you need. Um. Okay, okay. Okay, okay. Understood. Oh. Okay, so let me see. Yeah, let's talk about that for a while. I'm testing you on the very specific details. Okay, it feels that it's correct for me in general, right? Can I do that? Can I test you on the specific things?
Yeah.
Okay, so now, for example, this last one. Okay, according to the reactivity series, the H is here. The H is here. There, right? There's the H. Okay, there. That's the H. Something like that. So now, the H, then there's Cu, which is below H, and then there's Ag, which is below H lah. Okay. Now, do you find this to be weird or troublesome lah? I guess it's a question.
Yeah, I wanted to ask you about that.
Now, phrase it your way. Please ask. Phrase it your way.
If only a more reactive metal can displace a less reactive metal, why are the ones below H
Right.
still reactive?
Specifically, these two guys lah. Am I correct?
Yeah.
Specifically. And it is true that in practice, for some reason, it happens. In practice, for some reason, it does happen. Now, how do I explain this? Okay, now, first thing first, there are a few conditions. They never say the condition, but whenever you are presented with this in exam, they just automatically put in the condition. One of the condition is heat, so it's hot. Whether the gas is hot or better, the metal itself is hot. So metal oxide lah, let's say Ag2O, right? That's the silver oxide. The silver oxide is heated with a Bunsen burner. So it's not super hot, but it is quite hot. Then the hydrogen is pure. Pure. I mean, most of the time hydrogens are pure. Just want to emphasize that. And then they kind of how do I say? They kind of blast the hydrogen into the piece of metal. So let's say this is the AgO, which is very hot there with the Bunsen burner. And then the H2 flow is like blasting through it, something like that, blasting through. They basically blow it, okay? So there is a lot of work needed for this to happen. In normal temperature, normal condition, you just have hydrogen gas and AgO. That's not going to happen. I hope that makes some sense first. You need a lot of work to make this weird thing happen. Okay?
So silver and
Copper
only displaces hydrogen at high temperatures.
and yeah, definitely high temperature and a lot of flow and everything must be pure. And even then, it's not going to be very fast, but it happens. So I'll tell you how to I don't think even in H2 Chem in year 5 or year 6 later, they ask you to explain this. They just accept this to be, to be a reality lah, right? But maybe I can try, right? So if you give a lot of energy to this process, it can overcome that limitation in reactivity, but only to a certain extent. AG is the maximum lah. As you can tell, AU, I mean, the problem is AU doesn't even have an oxide. So you cannot even test it. If that makes sense. There is no AU oxide at all, right? That's the problem, right?
So
So up
is
to a
that
certain
what
level, you're saying, sorry?
is that what found uncombined?
Yeah, there is never a such thing as a gold oxide. Okay, so you cannot test it out because you don't have the oxide. Is it possible to make gold oxide? I think under very extreme condition, I think you can, which is totally impractical. We are learning chemistry, which are more or less practical. So to summarize everything, there are some ways to cheat the reactivity series. It's not fully rigid. You can overcome it to a certain extent. Everything can be done. It's just how extreme we have to go to. And in your syllabus, they are not interested in the extreme examples. They are interested in the more practical side of things, which I think is a good thing. Okay, now I'll give you another example. I'll give you another example, which should bother you, I suppose, right? So Fe is here. Now, this is the first one. Fe is below Al, correct? According to your note, Fe shouldn't be able to react with water lah, correct? According to your note. Okay, so far so good?
Wait, can you draw it? I can't see. Oh,
Maybe I'll
okay.
screen share. Okay, there. So this one, all right. Again, according to your note, which is correct, Fe shouldn't be able to react with water. Fe should stay just Fe pure. Okay. That's according to the note lah, because Fe is way below Al, right? Maybe around 3 or 4, maybe 4 steps lah in the complete one. But in reality, Fe Ras what? And Fe Ras with a minuscule amount of water in the air, a normal water vapor, Fe will rust already. If you put Fe inside a normal pure water, after 1 week, you will definitely see some evidence of rust. If you put it in salt water, near the beach, it will rust even faster. All those examples are definitely cold water. Cold water means room temperature water, and it doesn't mean ice cold water. Okay, do you understand what I'm saying so far? So this is another example of given a long time. Given a long time, and a long time just simply means a couple of days. Okay, Fe can react, no? Definitely within our experience. So this note is in general correct under conditions in a lab. In a lab, you never have a long time. In reality, you have decades in order to rust that iron. So it does work outside the lab, so to speak. Inside the lab, you got to make a more special experiment, right? So this note, although it is correct, but there are always exceptions, so to speak. There are always ways to overcome certain limitation. Is not fully rigid. And that's a practical knowledge. I hope that makes some sense.
Yeah.
Okay. So this is the situation of the node law, right? And if you can accept all that without feeling bothered by it, good for you. That means you're learning something practical. Okay, that's it. That's my comment for this note so far. I feel that those are the important things you have to put in. I'm very happy. Okay, any other questions?
No.
Okay. If you have no objection, we should maybe continue to make this note very quickly so that you can use it for your own learning lah. Right? The exam is 6 weeks from now. Am I correct? No, 1 month. 1 month from now, is it?
1 month. Yeah.
Oh, now, right? So I think we should have maybe 70% ready note by the time you start your school. I think that's good. Could you repeat for me again what's the topic for your exam? Oh, I have it already.
Yeah, redox, metal,
Redox, metal. Yeah.
energy changes, and rate of reaction.
Okay.
And I asked my teacher about the blast furnace thing, and she said
Yes,
it's tested.
it is tested. And now that I read your topic, obviously it's there. It's called extraction of metal.
Yeah.
Okay. Now, let me confirm that you still have no idea about extraction of metals. Okay. I will explain the principles, and then this is definitely going in the note. It doesn't take too much space, but hear me explain first before you put it in. Okay? We'll spend the 15 minutes doing that. After that, at around 7:30, there'll be more people. So at least we get that out of the way first. Because the other topics doesn't require a lot of notes. Yeah, the other topics doesn't require a lot of notes.
Like energy changes.
I'm sorry, you're saying?
Like energy changes doesn't need
Energy changes and rate of reaction, people tend to be able to understand and do the question quite well. Meaning just practicing should be enough. Right? There isn't any special. Of course, nothing stops you from making your own notes. Nothing. But there isn't anything very specific about energy change and rate of reaction. Maybe one or two things, I'll just tell you what it is. Okay? More important is to just practice the question. Okay, so I'm going to explain the blast furnace thingy, the extraction of metal in page 18, please. You'll have this drawing. I think as a visual person, the drawing will help a lot. We have now seen a real blast furnace. Okay, we don't have time. We don't have time. Okay, so a real blast furnace is very simple. This is a tall chimney. You're going to stack a few things. You're going to stack. You're going to stack coals. Very cheap stuff. Coal. Okay, you're going to stack coal with iron ore. I'm going to draw iron ore with yellow. So there's the iron ore. Gonna mix it, iron ore. And if there is nothing else, this is already more than enough. Okay. However, you need a rather high temperature. Okay, let's say 1,500 degrees Celsius. Very, very high. Okay. So this whole thing is made out of a material which can withstand 1,500 degrees Celsius. Well, you should know what that is. What material is cheap but able to withstand 1,500 degrees? For one, it's not metal. Not a lot of metal can withstand 1,500. So this is a temperature which is enough to melt most metal. An extraction of metal, this high temperature should be able to melt most of the metal. So don't make the blast furnace from metal. I think that makes some sense. Okay.
Wait, the blast furnace is the container thingy.
A container, super gigantic, big container thingy, industrial scale, made out of basically, bricks. That's it, bricks. Which is basically clay, right? Clay bricks. That's all. Okay, more than enough to withstand the temperature. Okay, so clay bricks and non-metal. Now, where is the metal in all this? It's iron ore, right? And then the final component, if you can say, is air being blown inside at very high speed. Blow the air inside and the air will kind of simply exit like that. Okay. Here, the air, what we need from the air is the O2. I hope that makes some sense. And here, you will get mostly CO2. I mean, a lot of things are burning, so the oxygen is just being burned and it becomes CO2. So far, I'm not quoting any special, anything made special, anything that makes little sense. Everything is just normal, even low tech, because blast furnace is very low tech in that sense. It's simple, easy, cheap to do. Nothing much. This is basically your barbecue with the iron ore, isn't it? Your barbecue have coal, your barbecue have air, you need to blow air to make the coal very hot, mix in the iron ore, and then suddenly, very weirdly, you will have, here's a drain, there's a drain here. Okay, you will have your Fe liquid melted and something else on top. One more time, huh? If you want your iron from your iron ore, just start your barbecue, put in the iron ore, blow very hard, you will get your liquid iron. You can just cast it on something and make it into solid Fe, whatever you want. Pretty simple, I must say. Let me confirm, you have never read or studied this before. This is the first time.
Yeah.
Okay. Okay. Now the equation is slightly more complicated than expected. Only slightly. I'll give you the most important reaction. I will ask you to memorize some, but don't memorize the balancing. I'll ask you to maybe balance on the spot. So memorize a little bit, but not the balancing part. Now, iron ore, Fe2O3. You are not very, you have to put more attention to formulas, chemical formulas. So please remember, iron ore is Fe2O3. Okay, so the most important reaction is your iron ore, Fe2O3. Is your raw material.
Plus H.
No, the H
It's
is not going to cut it. Yeah, it's not good. Okay, not CO2 also. So not CO2, because CO2 is useless. In fact, CO2 is the waste product. The waste product is CO2. As I said, it's useless. Waste product. It's also not O2. Strangely speaking, it's also not O2. Okay, also not H2. H2 is incapable of reducing the Fe according to your note, right? According, it cannot do that. Now, it will be CO, carbon monoxide. This is the maybe the unexpected thing, CO, because CO is super reactive. It is super reactive. It is way better than oxygen, not even carbon, sorry. Also not even carbon. It's not carbon, it's not H2, it's not CO2, it's not O2. CO is the best, the most efficient way of doing it. So I'm not saying that iron ore cannot react with carbon. Can. Iron ore cannot react with oxygen. It's already have an oxygen, so it cannot react, but it can react with carbon. But the better alternative is to react it with CO. Can you accept
I
that?
don't say it reacts with carbon.
I cannot hear you very well.
My notes say it reacts with carbon.
Yeah, wrong. Yeah, no, it's not carbon. Okay, I'll show you where the carbon comes in, because I do say that you have to put in the coal. I do say. Okay, I'll show you what happens to the carbon such that it becomes CO. Okay, I promise you it is not carbon. I promise you this. Can give me the benefit of doubt?
Yeah.
Okay, now here is Fe look. I mean, that's what you want, right? Yay. Right, so not very complicated. Your iron ore with CO, a bit weird, gives you iron liquid and waste product CO2. What is left is to simply balance this reaction. So please take this as an opportunity to practice your balancing. Ria, are you okay? Can you balance it? Mm. Ria, let me confirm you're balancing it elsewhere, is it?
Yeah.
Okay. Tell me when you're done, yeah? Because that means I cannot follow. Ria, are you done? It's a little bit longer than expected. Pressure, pressure. Oh. Your balancing seal is a bit rusty, perhaps?
Okay.
Ria, I'm giving you pressure, yeah?
Fe2O3
Write
plus
for me, write
3.
down for me. Write down in the same page. Come on, come on. We don't have much time. Come on, come on. Okay. Oh, you can just write down the number. Wait, what? Sorry, Ria. Are you saying that my writing here does not appear to you? Is it? Can you see this? Can you see this part of my writing? Can I confirm whether you see this or not?
Yeah. No.
Oh, the iPad is. No
Oh,
wonder.
I
No
see
wonder
it
we are
now.
communicating. No wonder we are. Ayo. Okay, next time when you suspect something is weird, please say something. Please say something. Right? Say something. No wonder it has been very long. Mm. Okay, 3CO and then uh, good, good, good. Good. Now, it is up to you whether you want to memorize the 1, 3, 2, 3. The 1, 3, 2, 3 is correct, but I propose that you balance it during exam and you don't have to memorize it too much. Memorizing carries the risk of, memorizing it wrongly, right? What you have to memorize is the Fe2O3 and all the state symbol. State symbol of CO2 is gas, obviously. State symbol of Fe is liquid. It's very hot. State symbol of CO is, again, gas, and this is a solid. That one you have to
What
remember.
other metals can you do this with? Everything
Your
that's...
mic is not good. Sorry. You saying?
What other metals can you do this with? It's everything
All right.
below carbon, above
Yes.
carbon.
According to your note, right? So your note does contain this, right? Reduction of metal oxide with carbon. There. Anything below
So it's
carbon,
everything
you can
below
use.
carbon.
Correct. But
But the rest is with carbon only,
electrolysis.
not carbon monoxide.
With electrolysis, plain and simple, anything above carbon, electrolysis is the
Oh,
cheapest way. It's already
like
very expensive.
like the ones below carbon,
Yes,
that's not Fe. Is it just plus carbon instead of carbon monoxide?
right. I'll tell you straightforward, yeah. This reaction is sometimes correct and sometimes wrong, but when the teacher or the examiner decides to bring in those reaction, they will give you the correct industrial reaction because you are not supposed to know. The correct industrial reaction for every metal is a little bit different, a little bit more complicated because it is more efficient. There is no way for you to know beforehand, so they just give you and ask you to work with it. That means this reaction is just in general, definitely a possible reaction, but unlikely to be the industrial reaction. I hope that makes some sense.
So they will say if it's plus carbon or plus carbon monoxide.
One more time. In blast furnace, there is no such thing as plus carbon. It is already the correct industrial reaction plus carbon monoxide. It is
But
not plus carbon. As well as with other metal, if they decide to bring it in the exam, they will
so
just give you the reaction.
that
Yes, you're saying?
equation is not accurate. The one
No,
with
it's
the
not accurate. It is one possible reaction, but it is unlikely the reaction they use. Because it is for a very simple reason. It's a very simple reason. The first guy is solid. The second guy also solid. You don't get much reaction from one solid and another solid. I hope that makes sense. That's why it's very inefficient. Does that make some sense?
yeah.
In order for the iron ore to react with the carbon, both are in a ball shape and both have to be packed very closely, and the surface area is still very small. Grinding them down takes a lot of energy already. Too troublesome. So let's invent another reaction. In this case, a solid with a gas. Oh, that works much better. For obvious reasons. Right. So again, the reaction that you wrote down, that part is not a practical reaction. It is just a possible reaction out of many. Okay. If you keep asking, then I will say to you straight, that is not the reaction. If you want a firm answer, that is not the practical reaction. It doesn't work very well. No matter what your textbook says. Solid and solid is never known to work well one in the lab and outside the lab also true.
But it says carbon gas.
Carbon gas. Have you heard about what carbon gas is? I've never heard about carbon gas. I have heard, however, of carbon monoxide gas, carbon dioxide gas, but not carbon gas. To be fair to you, I'm not telling you a principle. I'm telling you a practical reality. Sometimes you cannot argue with reality. The reality is solid and solid doesn't work. The reality is there is no such thing as carbon gas. That's the reality. I wish there is, much easier to work with, but carbon is solid. Carbon cannot be gas. If you burn it, it doesn't become carbon steam. It becomes carbon dioxide. Something like that. If it appears that you cannot argue with me, it is because I am representing reality. Reality just smack you in the face. That's reality. something like that. And chemistry does talk a lot about reality, which is sometimes weird for us. It's not a tidy principle. Yes. That's why I bother explaining all this to you. Can you accept that as reality, not as something very tidy lah? Yeah. It is a little bit untidy. Yes. Okay.
Yeah.
Abigail, I can see you. Yeah. Can you hear me? Okay, Ria. I'm asking you to integrate this into your note for now. I'll give you 4 more reactions, but the main reaction is this one. Okay. I believe the picture is very important, especially you as a visual person. Maybe you draw something small with it. I want you to put it in the right side of the page. It doesn't matter if you take too much space, you can always shrink it later on. Would that be okay, Ria? Okay. Once you're done, please send it to me. Yeah? Okay. Okay. Abigail, if you are speaking to me, because I see your mic having the signal, surprisingly, I cannot hear you at all.
Oh no,
At all.
I never said anything just now.
Okay, right. So Abigail, you can hear me now.
Yes.
Okay, good, good, good. Same
I'm
question from
uploading something.
good. I'll check the Jamboard immediately.
New one.
Are you using maybe AMAT Part 5?
Yes.
Okay. Is this part of holiday homework? Just checking.
Yeah.
Okay, again, remind me one more time. This topic has not been tested, correct? It will be tested in the future, correct?
Yes.
Okay, good, good. Okay. Oh dear. Can you do the first step? First question, first step, can you do it?
Uh. I'm supposed to do long division, I think.
No, not when you don't know A and B. The long division will just give you more A's and more B's. Does that make sense?
Oh, okay.
Right? So long division is definitely an important technique, but it's not working very well here because of the A and the B. Okay. Now for 4 marks, okay, this is from the time where you haven't prepared the topic before the school talk about it, right? Okay, so this is the effect law. We keep chasing the topic long after it's finished, right? But with the topics that you have prepared, you will see that they are very different. So I'll show you what to do. Factor theorem from x plus 2 equals to 0. Therefore, the factor is x equals to, sorry. The factor is, not much explanation, right? So I'm going to put this into the 6 minus 2 cube plus a minus 2 square plus b minus 2 plus 2. Will that be okay? And then this is going to be equal to 0. I'm not giving much explanation. If you're confused, you got to ask me. Remainder theorem. Your mic is not working very well.
I get the first part.
Good. The second part is very similar because factor theorem and remainder theorem is similar to each other. Same thing lah. This one, blah, 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 but equals to 36. That's it, look, because that's the remainder lah. Here's the remainder, which is 0, right? That's why it's called a factor. Okay. Now, I want to tell you about the motivation of doing this. The motivation is very simple. I have 2 unknown to solve, correct? I have two unknown.
Yes.
So mathematically, I need two equation. That's all. That's it. Correct or not?
Mm-hmm.
That's why the teacher or the question maker gives you two information of which you can get two equation. Two unknown, two equation, solve it by simultaneous.
Okay.
Right? Okay. Please do this. It does take quite a lot of effort though. It does. So please try.
Okay.
Ria, are you okay so far? How is it with the integration?
Yeah.
Okay. If you have done it, can I just see how you do it on paper? Yeah. On paper. Okay, Ria. This is the last. It looks about right. I'm gonna complete the blast furnace and the reaction. You don't need a lot of, you don't need much more space than what you have. Don't worry. Yeah. Okay. Abigail, where are you doing it? I cannot follow you.
Oh, I'm doing it on paper.
All right, good. As long as you're not stuck, it's okay. When you're stuck, please, you must ask me. Okay. Don't wait for too long. Right.
Okay.
Okay. So now I will give you, Ria, 4 supporting reaction. Surprisingly, there are 4, but the 4 I think is rather simple compared to this main reaction, right? So I'll give you right now. The reaction has something to do with producing the CO. The CO is not available, so we will produce the CO. The first 2 supporting reaction, the coal plus oxygen from air, correct? Oxygen from air becomes CO2. Nothing surprising, but a total waste. Am I correct? It's a total waste. Is this okay so far? Ria, if you cannot see in your iPad, just see from the screen sharing. I think that's better.
Yeah.
Okay, yeah. So one more time, the first reaction is a total waste. CO2 is useless. Like only the plant can use it. Okay, and this is a blast furnace. This is not to create more CO2 lah. But the CO2 will immediately meet with coal because it's very packed. Now this will produce the useful 2CO. You will notice that CO is a very dangerous gas, but it is, because it's dangerous, it is therefore very useful. Things which are dangerous are usually useful, right? So, but as a human being, you cannot breathe in the blast furnace. First of all, it's very hot. You don't want to get nearby. Secondly, there's so many CO flying around, it will probably kill us, either the heat or the CO. But the metal don't mind. The metal will simply melt with the help of the CO. These are your 2 supporting reaction. I hope it
So
makes
that is
sense.
how the CO comes into that.
Correct. You need the CO from these 2 reactions, so to speak. Okay, you do need to memorize them, but I think they are comparatively quite easy as long as you see them as a supporting reaction, not a main reaction. Okay, once you're done adding this, tell me, I'll give you the other 2.
I'm done.
Okay, now the other 2 takes care of what you will call dirt. The iron ore is dirty, correct or not? So when you put in the iron ore, like it or not, there will be dirt. Okay. We simplify the matter. The dirt is just sand. We are simplifying the matter. And sand is just SiO2. In case you don't know that sand is SiO2, now you know. This SiO2 does pose a problem. It get mixed around and it makes the final product rather dirty, which is not a good thing. I mean, it's dirt. Okay, so far so good.
Mm-hmm.
Now I will show you the reaction to handle SiO2. Okay, this is going to so this is the main reaction number one, and this is another main reaction. We'll call it to handle the dirt. Here's your dirt, SiO2. So, Abigail, are you okay so far?
Yes.
Okay, good. Now, Ria, if you remember from acid and base, if you don't, you tell me, right? In acid and base, you kind of learn that this is basically an acidic oxide. Do you remember anything like that?
Yeah.
Okay. So it shouldn't surprise you if I add another oxide, which is a basic oxide. Shouldn't be too surprising. Now, why would I do that? Because, of course, base and acid react, right? So when CaO and SiO2, even though they are both solid, okay, I'm now contradicting myself. Due to the immense heat, they do combine. Partly because the CaO crumbles very easily, right? There's always a exception to the rule, right? Most of the time, solid plus solid is not a good idea at all. But the sand is a small solid. The CaO crumbles in heat, becoming very small. So it works better lah than solid coal with solid iron ore. Works better. What happens with basic and acid? Well, they basically simply combine into CiSO3. We don't know what this guy is. They just call it slag. Slag is a fancy word for liquid dirt lah. Slag. The most important thing about this slag that it is liquid now. It is now
Where
liquid.
did the CaO come from?
Oh, a very good question. I will give you the last supporting reaction that makes CaO. You are right to question that. Okay, fair. I'll give you after this, but this is the main reaction first. Okay. So the most important thing about this reaction is that the SiO2 is gone. It is now replaced by a liquid slag. The liquid slag is here. There's the slag. And the slag do not mix with the liquid Fe. That is the beauty of the slag. It does not mix. The slag will be drained and thrown somewhere else. So this is a process of converting solid dirt, sand, into liquid dirt. Therefore, keeping the Fe liquid relatively pure. Do you understand? I will now give you the supporting reaction, okay? Supporting reaction. So the supporting reaction for the CaO comes from CaCO3. Okay, you call this limestone. Limestone, where do you get limestone? Oh, you get it somewhere. Okay, you get it somewhere else. The point of limestone is that it is cheap. Coal is cheap, air is free, iron ore not so expensive, limestone is also cheap. And with the help of heat, you have the decomposition reaction. I noticed that you don't have the decomposition reaction in your note. I do notice that. Now, this is the decomposition reaction. CaO plus CO2 waste. There is your Ca. Okay, do you understand?
The limestone is in what part of the blast furnace?
Yeah, you basically just mix crushed limestone into the blast furnace. Is that crude? Just mix everything in. And this thing will simply happen. No fancy stuff needed. Just put in. The heat will take care of it.
So all this happens in all blast furnaces.
Yeah, just put everything in. I'm going to draw the limestone. Yeah, I'm going to draw limestone. So the limestone are also kind of like crushed here and there. So there's the limestone. You really just put them in. Put. Drain the Fe, drain the slag. Put. Drain the Fe, drain the slag. Top up the coal. Top up the iron core. That's it. Simple stuff. Very low tech, so to speak. These are the 5 reactions, 2 main, 3 supporting. Put them in, and then I'll test you a little bit. Abigail, are you done? Now, can you solve the reaction?
I tried, but I got A equals like 53. So
Which is not the answer, right? So
yeah.
let's confirm that everything is correct first. You gotta check, I gotta check. Try, because there must be a mistake somehow, right? Okay, first I'll check whether I have a mistake or not. But you also check whether you have some careless mistake, right? I'll check and you check. So. Oh, I found a lot of mistake. Wait, what? No. No, I found one mistake only. One mistake. I did find one mistake. Yeah, I did find one mistake, and I want you to be able to find it. It is, I believe, a careless mistake. Okay, it is also a mistake that you keep doing. I therefore must insist that you find it yourself. Okay, if this frustrates you, well, it's better to be frustrated right now, right? It is better. There is a careless mistake. Ria, are you okay with the note?
Yeah.
Okay. The rest of the blast furnace is just some sort of application and all that stuff. This is the essential things. It doesn't deviate too much from this line, right? This is the basic stuff. All we have to do is just, practice some exam questions, right? If you have no other question, we should just finish the note here and move on to the next topic.
What about the full decomposition of metal nitride?
Right. So you have to add this in the note, right? So I'll add that. Now, first thing first, it is not the composition of metal. It is not. It's not. Metal is wrong, right? Metal don't decompose. The word decompose simply means one becomes more than one. More than one. Okay, usually by the process of heat, decomposition by heat. Not everything needs more heat. Something simply decompose by itself. But the word decompose in chemistry really means one guy becoming more than one guy. One guy by himself becomes more than one guy. Okay. Now, who is the one decomposing? It's not metal, but metal carbonate, which is very different from metal. I'll emphasize the difference. Metal is ion or not ion? Is it ionic or not?
No.
Correct. But this metal carbonate, is it ion or not?
Yeah.
It is. Right, correct. So this is metal ion carbonate. And the way they use the reactivity series that they kind of mix this up lah. They keep saying, okay, it's Na, and then K, and then Ca, and then Mg, and then, they just draw a normal reactivity series, which represents metal, which is very misleading. This is very misleading. It is not, I believe they are wrong in doing so. They say metal carbonate, but they use the metal side of things. Very misleading. Yeah.
So it's like
how
Na plus K plus.
correct. And in the reverse order, right? So I'll draw the reverse order. Look. So for example, now I will draw it as a Fe3 plus, right? Fe3 plus and then zinc 2 plus. Okay. I'll ignore the C4 plus. I'll ignore that there. Okay, because there is no such thing as carbon carbonate, right? And then there's Al3 plus, and then there is Mg2 plus, Ca2 plus, and then we're going to stop at Na plus, and then K plus. Okay. So this is the more appropriate way of saying metal carbonate. Everything with CO3, 2 minus lah. Okay, so far so good. Okay. It is okay so far, Ria.
Yeah.
Okay. Please note that your other note is correct. They are talking about metal. Okay, but the moment you talk about, for example, metal oxide, it is already misleading because metal oxide is not metal but metal ion. So your metal oxide has the same problem with the metal carbonate. It's very misleading to use the metal side of things. Just like this. So now for metal carbonate, you notice that this is very stable, correct? This is very stable down here, and this is quite stable. Because it's already ion, by nature, it is already quite stable, but the more you go down, the more stable it becomes. Okay, make sense? Here's the limiting
So
line.
it's reversed.
Can decompose. This one cannot. Simply because it's already too stable. I hope that makes sense. That's the line. No? It's always just about a line. Okay. Your calcium carbonate just telling you is here. There is your calcium carbonate, isn't it? There. Ca, CO3. The last guy that can be decomposed, it decomposes around 1200 degrees. Just saying, slightly below the blast furnace temperature. It requires such a huge, such a high temperature to decompose calcium carbonate. The moment you get to sodium carbonate, it no longer can decompose. I hope all this makes sense. That is your note. Yes, Adia.
I still can't find it.
That should bother you a lot. I can only give you a hint, Abigail. I really mean that you need to find it. I really mean that you need to find it yourself. You cannot rely on me. I'll tell you that the problem is somewhere here. If you still cannot find it after 5 minutes, you have to contend with leaving it for a while, and maybe next week, still holiday, we'll try again, right? But I will not tell you what your mistake is. This is so that you will remember it. Okay, there's a mistake here. Go and find it. That mistake will cost you 6 to 8 marks in exam if you don't correct it. If you have any trouble, tell me, Ria. If not, just send me a picture. It will be enough.
What about metal nitrate?
Metal nitrate are not of interest. Metal sulfate, metal nitrate, they are more towards the solubility. So metal nitrate is usually mentioned not for reactivity series, but for solubility. There's something you have to memorize for acid and base topic usually. Since your exam does not include acid and base for now, that means metal nitrate, metal sulfate, and everything is not in the note right now. You should have the note for final exam use lah. Am I answering your question? Again, when you have sent me, please tell me. Abigail, are you still having trouble?
No.
What is the mistake? Tell me. What did you find?
Negative 4A.
Which is supposed to be?
Just 4A.
Very good. I was not joking when I say this will cost you 6 to 8 marks in exam. It happens like that one. Because this is like something that always happen no matter what the topic is. The moment you make this mistake, you're very likely to make another mistake in exam. Please correct this in your mind, no matter how it takes.
Okay.
No matter what it takes, you have to fix this. Now, hopefully, you'll find a better answer. Please tell me how it goes. Ria, are you okay? And Abigail, are you okay?
Yes.
Good. Oh, Abigail, so it works, is it?
Yeah, I'm doing it right now.
Okay. How about you, Ria?
Yes.
Oh, you sent me something. Okay, good. You
that
want me to
was
see your note, right? Oh, the thermal decomposition of carbonates, look. This is what I'm telling you, look. The way they explain it is very confusing, look. I would rather that you do it from the ion side of things. I hope that makes sense, yeah. There you. No, please don't do this. Please don't flip the ion like that. Then it's useless already, right? The ion should be done in reverse. I hope that makes some sense. If you do it this way, then it's almost like doing it like the metal side of things. It's very confusing. I mean, I'm glad if you're not confused, lah, but can you guarantee that 3 months from now, when 3 months from now, when you have forgotten about this and you're revising for your final year exam, will this confuse you? If there's a chance that this confuse you, maybe you do it my way, you reverse the order. Makes more sense. If my advice doesn't make sense, please tell me, okay? I'm not forcing anything that doesn't make sense to you.
Okay, I got my answer.
Yes. Yes. Oh, as in 17 and 11, you got it. 4 marks. Okay.
Yeah.
You look at the steps are easy to understand, I hope. Like vector theorem, perimeter theorem, simultaneous equation. What can be simpler? But the process is fraught with careless mistake. That is the general downfall of this topic. This topic is fraught with careless mistake, and I would encourage you to see it as an opportunity to grind away your careless mistake.
Okay.
See it that way, in a positive light. Now, one more technique I have to teach you. Do you know that you can solve simultaneous equation with your calculator?
Yeah, I think I've seen it before.
Okay. Now, what I'm teaching you is this. I'm teaching you to make full use of it to give yourself a certain solid feeling. Before you solve it manually, I want you to basically type in the calculator and then get an answer. That won't give you any marks, but will give you some sort of like a high morale. In exam, high morale is very important. Very, very important. Could you please just do that? Could you just make sure that in the calculator, it is quite easy to do? That's the point here. It's so easy to do. It will almost be a waste if you don't do it.
Yeah, I got it.
Okay, good. So easy, use it for high morale, not for getting marks. Understand?
Okay.
If you do the calculator and you realize your answer is wrong, of course, your morale will drop a little bit, but now you have an incentive to find the careless mistake, so to speak. Okay, I hope that makes some sense.
Okay.
Okay, now hands, right? Priya,
Yes.
can I confirm that you're okay?
Yeah.
Okay. Tell me when you're done or your sense of. Now, the
Okay.
hands simply means like, oh, now I know the A and I know the B already, right? I
Yeah.
just plug it in and then solve it. Are you saying that you do not know how to solve a cubic equation?
Yeah.
Long division. That's all I can say. I would like to remind you now is the time to use long division because there is no more A and no more B. Can you do something?
Yes.
All right, give it a try. Because I believe you have the concept in mind already. You just don't know which one to choose. Oh, you're doing it here. I like it very much. Yeah, I do not know why your note has a column for thermal decomposition of metal nitrates. That is definitely outside the syllabus. Even the column
Yes.
seems empty, like it's a bit weird to me. I've never heard about it before, right? I mean, in the syllabus, outside syllabus, of course, have. But nitrates are notoriously difficult to decompose. So. Okay, good, Abigail. That's a good start. Ria, are you done?
Yeah.
Okay. Maybe just take a picture of the whole page so that I can see the general position of things. Okay, nice. It's not very cramped. It looks like you have everything there. Everything is nice. Yeah. Okay. Let me confirm that you're comfortable, generally comfortable with this note right now.
Yeah.
Right? It's a combination between my knowledge and your knowledge. That's the best thing. That's the best kind of notes. Okay. Any other question that you are aware of for reactivity series, metal extraction, and whatnot?
Sorry to repeat.
That means topic number 2, metals. Any question that you personally want to clarify? If there is nothing,
Wait, for rust prevention, is it just like memorize the method? That's it.
you do have to memorize the method. So oil, paint, sacrificial protection, galvanization. But galvanization is not sacrificial protection, I guess. So they are basically 4, right? Oil, barrier lah. Oil, paint, sacrificial protection, and galvanization, which is not sacrificial protection.
But there's 2 more.
Which is?
Coat with a layer of SN.
Coat with a layer of what? I'm sorry? Coat with a layer of what? SN. Oh, you mean thin SN?
Yeah.
That is sacrificial protection if you know where SN is. Correct or not? SN is below FE. Oh, wait. Oh, no, I'm sorry. I'm so sorry. I mentioned something wrong. Huh? I'm so sorry. Let me correct myself. In the reactivity series, I'll use this one. Zn is above Fe. So they call this galvanization, right? Galvanization is sacrificial protection. I say it wrongly. Does that make sense?
What?
Okay. The word galvanization is a very fancy word for coating Fe with zinc. Clear first?
Yeah.
Do you understand the concept of sacrificial protection?
So the ones on top react first.
React first and react solely. So the metal below will be fully protected, so to speak, fully protected. right? So galvanization is nice because first it coats. Secondly, it is sacrificial. The zinc, when the coat is broken, the zinc will still protect. This is in contrast to paint. When the paint is scratched, the protection at that point is no more, which is a bit dangerous. The rust will go deep. So galvanization is popular because it is cheap, it is effective. When you coat with SN, it is usually used basically for, well, tin can, but old technology. Nowadays, aluminium is the favorite thing, not tin. Okay, but old technology, they use basically tin layered, Fe layered with tin. That's why SN is called tin can. Okay,
Okay.
but SN is below Fe. So can you imagine a can of food, which if you scratch the inside, it becomes rusty. It's very icky and it's very dangerous. Old tech look, that's why they don't use it anymore. Lah. They don't use SN coated Fe already. Because it is the reverse of sacrificial protection. I hope that makes some sense.
Yeah.
Aluminum can is just way better if possible. I mean, do they still use the tin can method? Some still do lah, but with a lot of improvement lah, because it's just so, it's just so, it's just so not good lah when it's broken. It's just not good. Is there any other method that I haven't mentioned? Abigail,
Oh
you have
wait,
been,
there was
yes,
No,
go ahead.
make,
I'm doing it
making
on paper.
Good, Abigail. Sorry, Ria, you're saying?
making stainless steel.
Oh, yeah, stainless steel is fine. I guess stainless steel is fine. I understand, right? They are not very interested in talking about stainless steel, surprisingly. They are more interested in talking about the other method because if you want to protect a ship, you cannot make the whole ship into a stainless steel ship. It's too expensive. Stainless steel is a very expensive option. Chemistry is very practical. We don't like expensive options. We don't like. I hope that makes sense.
Also, I realized I added redox stuff to the cheat sheet, but I forgot.
I don't see any redox stuff in the cheat
Yeah,
sheet, but
it's
I'm very happy if you do it. Do you want to show me?
Yeah, it was on the other page.
The other page.
Yeah,
Where is it? Where is it?
I'm
Where is
sending
it?
it.
Oh, okay. If you like, you can show me because I have an impression that you're good at redox. That's why I don't have much comment for you.
I'm kind of for redox. I'm kind of confused on oxidizing and reducing agent.
Oh, let me read first. That's a very long one, but it feels right on track. Okay, so I'm gonna copy that first. Okay, I'm generally happy, but let me read it. Okay, I'm seeing some answer, Abigail. Okay, good. Okay, I'm in page 20, Ria. I'm just reading your note, yeah? Then please ask me where your confusion is. Let me read for a while. Oh, yeah. I like all your exceptions. Okay, your notes are great, of high quality. Okay, yeah, whatever. Yeah, it's nice, whatever. I think this is unnecessary, but it's okay.
Wait, which?
This is okay-ish if you want. Okay, I'm bothered by the fact that there is no KMNO4 here. So you don't put in the chemical formula. That's not okay at all. You need to know the chemical formula. This is K2Cr2O7. So the MnO4 minus is the purple one. Okay, and you need to know that it becomes colorless. So Mn2 plus, this is your colorless one. You need to know all these details lah. So the Cr2O7 2 minus is here the green, and the orange one is the CrO3. CrO3. Yeah, what's the... Wait, I forgot the ion charges of CrO3. Let me check. Okay, let me confirm, Abigail. Your last final answer came from pressing the calculator, so to speak. Am I correct?
Yes.
Good, good, good. Yeah. Just add the first answer here also. You need to put this, and that. Understand? You need to put 3.
Oh, okay.
Make sense? Because you have 3 equations, right? If I tell you long division and you can do it, that means you can see for yourself, you already know all the techniques. You just have to know how to use them. That's very important, but you're not lacking much. Okay, apologies. I have to check CrO3. What is the charge? I believe it's minus, right? It's taking very long. There you go. Oh, CrO4 2 minus. Okay, I made that mistake. Sorry. CrO4.
But it says are
You're saying, sorry?
wait, is this about acidified potassium dichromate?
Yes, there is the phrase acidified, even though in year 4 you do not know what that means. But yeah, acidified lah. I'm just
But
talking
it
about the
says
potassium manganate though.
oh
Right. The acidified doesn't mean much to you right now. In year 5, no, in year 6, it will mean something like year 6. But they kind of insist that you say the word acidified. So, am I answering your question?
yeah.
Okay.
But
So,
wait, so for oxidizing and reducing agent, you just have to know like
yeah,
the
it's
observation.
you have to, together with the ion formula and everything. This detail you have to know it, memorize it. This is your know. Understand? Okay. This is memorizing. No, there is no other way around it. Okay, so Abigail, I take it that you don't understand the hence. Am I correct?
Yeah.
Now, hence is a very common closure, right? For 2 marks, I believe. Could you check for me? This is around 2 marks?
It's 3.
3, right? 2 or 3. You may be bothered by the fact that, oh my goodness, I do not know how to do this at all, right? Furthermore, this happens almost every time. There's always a hence at the end one. Okay, now I would like to say a few things. Even though it can be 3 marks or 2 marks, but if you understand, it is easy to do. If you don't understand, it is almost impossible to do. So it's very clear-cut one. If you don't understand this, after a while, leave this and do other question. I really advise that. But if you understand it, good for you. You will take not a long time to settle the hands part. So if you can understand, good. If not, I don't think it will cause you to fail. It is just the hardest part of the question. The previous one are more basic and more foundational. This one, they start to get creative. That's the hard part. Can you accept that for now?
Yeah.
Okay. So I'll try my best to explain, but you must understand this. This will appear very different every time you see it. Whereas part A and B will appear quite similar from question to question, because part C is the hard part, and part C, they get very creative. Yeah. Now, I explain it this way. Since the word hence, therefore, No matter what this is, I'll put a question mark here. What the heck is this guy? No matter what that guy, the first thing I do is to find the original equation somewhere here. What is the original equation? I'll put it here. Okay, Abigail, I'm giving you an island of stability. When the question appears too confusing, but you still want the marks, I guarantee you, finding the original is always a good thing to do, right? So you just put this in mind, okay? I'm not asking you to write it down. I'm asking you to find it here. Now, please notice that, for example, this is 6. The only problem is that this is 4. This is 2. But the rest, and this is I don't know also. But the rest are quite agreeable. Understand? The rest are quite agreeable.
Yeah.
Oh my goodness. Oh my goodness. Oh, oh dear. Oh wow, this is tough, man. Wow, 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 wow. Ria, are you okay?
Yeah.
You said that there's something confusing with redox. Did I actually address that confusion?
I mean, confusing as in like, I didn't know if it was just memorizing. Like, I sent you like my notes.
Your notes is very complete.
No,
I don't
like
mean that
my
as
school
something bad.
notes.
I mean it as something, yeah, this is the first draft lah. A first draft will look like this, no?
Like, I sent my school notes about oxidizing and reducing agent.
That explains how complete it seems, except that I'm very confused. How come you don't have the chemical formula lah? And that's the only thing I correct. Everything looks well. The question is whether you understand or not. That's actually the question. Because all this doesn't help you much in the real question if you don't understand them. I have a feeling that you do though. So, I mean, as a first draft, I have no comment lah. It's great. I'm looking forward for the second draft. If that's what you want to do.
Wait, so is that it for those two chapters?
For our first draft lah. Yeah, for our first draft. Okay, Abigail, I'll need some time to confirm whether there's a mistake or not. Could you please pose another question so that you have to wait for me?
That's it.
You only have one problem, really.
Yeah.
Oh, it's not that bad. Okay. Now, tell me, Abigail, do you want to talk about other subjects' homework first?
Let me see.
Yeah. Try to ask the difficult one. Then next week we can focus on, addressing the future, right? The future aim as for a good student. Now, Ria, are you happy with the redox side of things? It looks fine to me.
It's just a lot of memorization.
Correct, Ria. I'll tell you something. Remember what I told you? There are always 3 steps of doing a note. First is that you dump everything. You are still at that level, the first level, but at least it's everything. And that's why it appears like, my goodness, there's so many things. And furthermore, it might not be very relevant to the exam, but at least it's everything. So you're just dumping everything here and it doesn't take too much space. That's good. Okay. I guess that you summarize a little bit from your note. It still doesn't count as the second level. What is the second level? The second level, you start to arrange things according to what is more relevant and what is less relevant. Okay, the second level kind of explain. Sorry, yeah, I think Jamboard have a lot of problems. Uh-oh. The second level is the rel. Okay, I cannot write anything here. Right, I have a problem here. Okay, anyway, the second level is relevance. You can only make a more relevant note after you have done some question. So you write it based on questions, not based on notes. I hope that makes some sense here. Basically, this is the best you can do right now without referring to any questions. Once you refer to questions and you realize, oh my goodness, certain things are just not very important. Certain things are very important. You can start to minimize or reduce until what is relevant only. You can only achieve that not by reading notes, but by doing questions. Okay? Most people, if they can achieve the second level, is extremely good, extremely well prepared for exam already. Okay. Okay, one more time. This is the best that you can do right now. All you can do to improve it is to now start to do questions. Nothing else. Don't start to memorize this. It's useless. It's totally useless. You memorize this right now, it cannot last for 4 weeks. Just leave it like that. It's totally fine. You are considered quite diligent and quite early in doing all this. Some people make this dumb 3 days before exam. Totally useless already. Like, just totally useless. You are doing a very good job right now. Can Ria? Okay, now Ria, we have 3 more minutes because I would pretty much like to do the questions for you the next time we meet, right? Is there anything else you want to clarify for the notes?
Is there anything that's like needed, like super important for energy changes and rate of reaction?
My question to you is, do you think you can do those topics questions currently?
Energy changes is okay, but rate of reactions, I have to see.
Now, to encourage you, it is a very common experience with everybody else. People don't tend to need enthalpy notes and rate of reaction notes. They just need practice. Even after practice, if you don't make any note, it's probably going to be okay. It's a bit different from the other topics. They are quite doable and manageable. So if you don't have notes for your cheat sheet in those 2 topics, but you practice a lot already, it's gonna be totally fine. If you still feel not so at peace, I will tell you what you need to put, but don't worry, it's a very small thing. Okay, very good. Have I answered your question?
Yeah.
At this stage, I will tell you the only way to improve your note is to do questions and immediately notice what is missing. Oh my goodness, my note is not helping me in a certain way. My note is helping me in some other way. I'm going to strengthen what is helping me, and I'm going to add what is not helping me based on the questions I'm doing. That is, your notes will come out very mature and very, very solid. Very solid if you do that. Now's the time. You're ready. No more reading. Don't read already. Do questions by looking at your cheat sheet, so to speak. Do you understand? Can you do that, Ria? Ria, can you do that?
Yeah.
So do your homework, at least 2 papers, because there isn't much topic, right? There isn't much topic for this exam. Use your cheat sheet immediately. Just use them as you would for your 2 paper homework. We will immediately have quite a lot of useful things to discuss next time. Okay?
So should I prioritize like the practice papers from school or like 10 years?
From your school. From your school. Your school standard first lah, is what I'm saying. Your school standard first. The 10-year series will be useful later on, no problem one. Okay, you can use your school's paper first, no problem. I'll tell you that the 10-year series is slightly too easy in certain topic for your school and slightly it's a mix of too easy and very complicated. I don't know how to explain it. So don't use 10-year series first, is what I'm trying to say. Okay, don't use that. You're not ready. Okay, there are certain quirks that we haven't talked about too much. So please don't use it.
So like
Okay.
watch.
Just ignore it. Use your school paper.
Okay.
Maybe I'll ask for one or two extra session next week. Make sure you already tried your school paper, 2 of them. Would that be okay? Your note is in the best shape already. You cannot do much else. Just do questions.
Okay.
Maybe I'll see you next Monday or next Tuesday. I don't know. We'll just WhatsApp. When will you be back?
Next Saturday.
Oh, okay. So I guess that's fine. All right, Rian. Still a good job today. I hope you feel that you have progress because I think you did. I'll see you next week. Bye. Okay, Abigail, thank you for muting here. Can I confirm you have no question for chemistry, physics, e-math?
No, I've already finished like all the homework. There's nothing.
I like the sound of that. Tell me, Abigail. Last year, are you this diligent?
I don't know.
Like you finish your holiday homework 1.5 weeks before school starts. Some people haven't done anything 3 days before school starts.
We have finished like most of it before school ended. But, like
You already finished sounds even better, I guess. Good. Don't mind. Okay, I'm in the process of confirming whether there's a mistake with the question or not. Oh, wow. There isn't. This question is scary. Okay, watch what I do, okay? Watch.
okay.
This is very, it's too much. It is too complicated. Okay. Now, to make it slightly easier, I'm going to change the x to y for now. I'm going to write 6y power 4. I just realized what is supposed to. Okay, so far so good?
Yes.
So far so good?
Yeah.
And then I will door times y squared. Well, partly because I dislike this guy. I don't like this guy. Okay, so that's a very strong reason for me to do it. Okay, so I'll do that. Things seems to get out of hand. So far so good?
Yes.
Until you realize there is some good news. There is. Okay. The power 6, you know, we cannot do it already. Okay. Power 6 is not something that we can deal with. The most we can do is binomial, and this is not a proper binomial question. Fair enough?
How did you get power 6?
Door times y squared. Tell me if it's confusing.
No, it's okay.
Okay. So again, the motivation is largely this guy. Okay. Now, y power 6 and y power 4 is not within our ability to deal. Only in binomial we can deal with such a big power. And this is not a binomial question. Am I making any sense?
Yes.
I'm telling you all this so that you are not phased. You should remain unfazed. There is nothing wrong with this. There's also nothing wrong with the question. Nothing wrong with you also. Why? Because look, 6 and 6, 17 and 17, 11, 11, 2 and 2. Okay? This is good news. Therefore, I will conclude that y squared is equivalent to x.
Yes.
Once you do that, the mystery is solved. Y power 6 no longer holds any power because it's just y squared equals to x. They're equivalent there. So if you see, this is just the same thing, ma. This is just, y square lah. And this is y squared cube. Power 6 no longer matters much. Do you understand what I'm saying?
Yeah.
Okay, so I will just hold guide a conclusion here, and then I'm off to answer why there are no real roots. Very simple. We will now use your previous answer. The Jamboard is showing a lot of error, and I don't think it's anybody's fault. Jamboard is really there you go. Okay, I'm putting it here. So therefore, y squared equals to minus 2, y squared equals to minus 100, y squared equals to minus 100. Okay, so far so good?
Yeah.
Therefore, y doesn't exist. Correct or not?
Oh, yes.
Yep, that's it. And we have answered the question. But it's it will be unnerving if you see this in exam. Yes? Miguel, don't be too bothered. Just take this as something new first. Nearer to exam, if you're still interested, we'll practice more. Just remember that the majority of the mark is not here. It's above. Okay. That's the more important. Let me put it another way. You can score A by totally ignoring this part. You can still score A. No problem. Okay, Abigail.
Yes.
When you're done, I want to move on to the future topics. Yes, please. Okay, tell me when you're done.
Okay, I'm done.
Okay.
Okay.
The
The
steps makes some sense. Yeah.
A bit.
Okay.
Okay.
A bit is fine.
A bit is fine.
I will make
I
one
will make one
promise.
promise.
After you
After
done
you
a
done
few
a
of this
few
type
of
of
this type
question,
of
you will
question, you will
notice a very
notice a very
similar
similar
patterns.
pattern.
The question
The
is
question
very
is very
weird,
weird,
but the way we
but the way
handle
we
it
handle
is
it
very
is
similar.
very similar.
If you
If you
can
can
arrive at that
arrive at that
conclusion,
conclusion,
you stand a
you
good
stand
chance
a
of
good
winning
chance of
exams.
winning exams.
If you
If
don't,
you don't
be bothered by it.
bothered by it.
You should be more
You should be
bothered
more
by
bothered by
careless
careless
mistakes,
mistakes,
doing
doing
the
the
first part and the
first
second
part
part
and
of the
second part
question,
of the question,
or partial
or
fraction.
partial fraction.
Everything is just more
Everything is
important.
just more important.
Okay.
Okay.
Now,
Now,
you don't
you
have
don't have
any exam
any
schedule,
exam
right? For
schedule,
term
right?
3,
For
right?
term 3, right?
Let me check.
The schedule and the topic.
and the topic.
Okay, if you have,
If you
that would be
have,
very
that would be
nice.
very nice.
No, I don't have any news for now.
Yes, Abigail.
Yes,
Yes,
Abigail. Yes,
I don't have any news for now.
understood.
understood.
Okay, so let's make
So
some
let's make
guesses.
some guesses.
Let's make a
Let's make
guess
a
for
guess
A
for
math
A math
topics.
topics.
What would the A
What would
math
the A
topics
math
be
topics be
for
for
the next
the
exam?
next exam?
For example,
For example,
the
the
polynomials are right.
polynomials are right.
Yeah.
FT,
FT,
remainder
remainder
theorem, long
theorem,
division, partial fraction,
partial
right?
fraction, right?
Yes.
A lot of marks,
A
right?
lot of marks, right?
What's the next
What's
topic?
the next topic?
Let me check. Binomials
Binomials, very good.
Binomials, very good.
and logarithms.
Logarithms, okay, makes sense.
Okay, makes sense.
Anything else
Anything
besides
else
these
besides
three,
these
you think?
three, you think?
Probably not.
Okay.
Okay.
Correct me if I'm
Correct
wrong.
me if I'm wrong.
You were
You
already
were already
learning
learning
coordinate geometry.
geometry.
Correct or not?
What?
The last thing
The
you
last thing
learned
you learned
before
before
holiday,
holiday,
is it binomial?
binomial?
No, it's logarithms.
Oh, logarithm.
Logarithm.
Okay, so let me confirm one more time. You have never heard about coordinate geometry,
geometry.
No.
linear logs,
Linear
no?
log, no?
I think I've heard of it.
Okay, if you marry logarithm with coordinate
with
geometry,
geometry,
you get linear
you
log.
get linear log.
So it's just a
So it's just a
natural
natural
continuation.
Okay.
Okay, circle coordinate geometry. And then finally trigonometry. Now let me give you some idea comparing this with the the end of year exam.
Okay.
So this will be your term 3, right? Okay, probably. And this will probably with end of year. And then we'll talk about term 1, term 2.
Are you writing anything?
I am in the sorry. Okay. Remember, in Jamboard when we type, it doesn't show, and then when I exit, then it will show. That's why.
Okay.
Okay, so I'll give you an idea using the possible marks, right? So the possible marks for polynomial is, let's just say 4, 3 plus 4 is 11. Okay. Binomials is at least 7, and logarithm is just 4 plus 4, something like that.
Okay.
Once you learn coordinate 3, you will see that this is at least 10. Linear law is at least 8. Circle coordinate geometry at least 8 also. And then sum trigonometry means 4 plus 4. I'm guessing that maybe your teacher will not be able to cover the trigonometry part, which means your sec 4 will be more packed, like way more packed. Now, for term 1 and term 2, let's repeat the topic one more time. It's the quadratic with discriminant, correct?
Yes.
Discriminant inequality, right? Something like that.
Yeah.
And then you will have your indices, correct?
Yes.
Is there anything else?
Certs.
Certs. Anything else?
Let me see. No.
Maybe some sketching of power law graph. The sketching of power law graph is what you remember. I was encouraging you to learn from the textbook before the school. You were actually doing this with Desmos, right? That's what we did. And this is maybe 3 marks. Something like that. Yeah. Now, certs in end of year will be worth 7 marks, maybe. In this, will worth maybe at most 4 plus 3. 4 plus 3. Then this one will be worth also 4 plus 3. Okay. Now, you go ahead and total your term 1, term 2, total it, and then you go slide down. Just total this one, and then total. So the last one I will say, maybe your teacher will finish the first 2 only. This is like the minimum before end of year. And this is like the maximum. Okay. Now, when you look at the total, I still believe that I'm correct. Your term 1 and term 2, when you total everything, it's still worth less than your term 3 topics, or rather the term 3 exam topics. Definitely still worth less. Okay. Gives you a lot of motivation to strengthen this, because your binomial is not bad, your logarithm is also quite stable, and all those stuff. And your polynomial, I think you got most of the principles correct already. Okay. So focusing on term 3 will benefit you a lot for end of year. Let me confirm one thing. Your end of year will be everything. Correct or not?
Yes.
So your end of year ratio looks like this: 29, minimum 18, and around 23 for this. Focusing on your past is not the most productive thing, even though your past seems to be not good. Correct?
Yes.
Your past is not good. Your past is not good because you weren't a good student. You were a reactive student. You weren't preparing. But even if that is true, I still think the priority for temuan tentu is not so much, considering the marks proportion point of view. I hope this makes sense.
Yeah.
Okay, so now you have a few options moving forward. You can fully focus on this, and therefore, at the start of term 3, you are super ready for the exam already. Okay, that's one thing we can do to simulate exam. You can also start doing this because there's a lot of mark at stake. Because if this question, this big marks are kind of easy to get once you're stable. So that also helps you. Okay, so those are the two directions you can choose. Please choose for next week. What do you want to do?
Focus on the future.
You're talking about this thing?
Yeah.
Okay, so this one we consider it just enough for now.
Okay.
Okay, sure. No problem. We'll start with correct geometry. We'll move to this and this. But these three, a lot of marks. Okay, I will start by showing you one question. I think we should end it. Let's see. We're going to study this topic without referring to your textbook. It's faster.
Okay.
Be afraid. This is an exam level question. Do not be afraid. I will show you what is important. Oh yeah, okay, done. Now you need some image. All the shapes. I mean square, rhombus, rectangle, parallelogram, side, trapezium. You need all this. Okay? If you do not know, you will quickly revise them one, guaranteed. You will know their properties and everything. They will assume that you know. They will not tell you. Besides the fact that, this is a hence or otherwise prove that this is a kite. Where you better know the characteristic of a kite. They won't tell you. Okay? So first, imaging. Secondly, image line, which is why I'm expressing. Okay? If you forget, don't worry. We'll use it quite often. You will remember. You'll use a few new things from image. Okay, so for example, parallel, m of grade m1 equals to m2. If two lines are parallel, their gradient is the same. Make sense what? Okay?
Yes.
Now, if two lines are perpendicular, it's a bit new. Let's say m. Give me a number.
3.
Okay. To spice things up, 3 over 2. Okay? If it is perpendicular with gradient line 2, this gradient will be flip. Flip the sign, flip the fraction. Understand? I'll show you. Look at my Desmos, please. There, I've drawn a line whose gradient is 3 over 2. I'm drawing another line whose gradient is minus 2 over 3 x. Do they look like they are perpendicular?
They do. Yeah.
Okay. Of course, you have to measure it, but at least it looks correct. Give me another random gradient.
Does it does it have to be a fraction?
Most of the time, it is. So let's practice.
6 out of 5.
Okay. Spice things up. Minus 6 out of 5 x. Okay. There you go. You need another line which gradient is perpendicular. So tell me how to do it. Flip the sign, flip the fraction.
5 over 6.
Positive, correct? Emphasis. There you go.
Okay.
Looks perpendicular. If I do plus 2, doesn't change anything, isn't it? Correct? Look at that. Make sense?
Yes.
Okay, so that's the perpendicular gradient. Just to make sure you understand. If I have a simple line, half x, tell me, what's the line perpendicular to this?
2?
No.
Negative 2.
Very good. Check it out. Doesn't look like that. Okay. So that's new for A math. Nothing complicated. I will teach you a few more things. How to find midpoints without memorizing the formula. Midpoints. And then similar triangle. I'm sorry. Similar triangle turns out to be from EMATH also. So similar triangle. There you go. Area. A new area technique. So this question, the correct geometry question, always have a picture, always have this graph, always have a lot of marks, total 11 marks, always ends with the area. Okay. That's what you should expect in exam. So that means if you understand this question, all you have to do is practice a bit, and you feel quite okay already. Okay, that's all for introduction. I will show you the next time we meet. Maybe I'll request 2 or 3 sessions next week. Would that be okay?
Let's see.
Not to cover A math only. You still have your science. Right.
Yeah. Sure.
Glad to meet you today. Let's
Okay.
talk to WhatsApp. Good job. Bye.
Bye.